We're doing sections 6.2 and 6.3 out of sequence. I've already done the videos for section 6.3 and showed you how to factor a trinomial in the form ax squared plus bx plus c. In this section, the section before that, we're going to factor trinomials of the same form, but where a is 1. In other words, in the problems in this section, you won't see a number in front of the x squared term. Like this one here. ax squared plus bx plus c is 1x squared plus 8x plus 12. I can write the 1 or not. But we're going to use the same technique as I showed you in 6.3. We'll start by finding the product and the sum, where the product is the first number times the last number. In this case, that's 12. If I'd shown you this section first, you'd have started thinking of this number as your product. You get so used to that when we go to 6.3, you forget to multiply it by whatever number happens to be in front here. That's why I showed you 6.3 first. Now that you know that you're supposed to multiply A by C to get your product, it's safe to show you this. The thing is, a lot of people find these problems a lot easier. And they usually are. But you will occasionally find problems that look like this, but with really big numbers here and here. So it helps to have a strategy that's foolproof. This one looks easy, but it can still be done using the same technique, and that's how I'm going to be doing my factoring, even on a simple problem like this. Okay, so I found my product. It's 1 times 12, and my sum is 8. Everything's positive here, so I don't have to worry about the signs under my product. I'm looking for a positive times a positive to give me a positive product, and I have a positive sum. So whatever I come up with here, it's going to be a positive times a positive and a positive plus a positive. Everything's positive. Okay, so how can I write 12? Well, 1 times 12, 2 times 6, or 3 times 4. And when I add these up, I get 13, 8, and 7. I was looking for 8, and here it is. The way to build 8 is by using 2 and 6. So I'll rewrite this problem, the first term at the front, the last term at the back, and the middle term split up into two terms made up of 2x and 6x. What's common to these two terms? They each have one copy of x. This one has 2 copies, but this one only has 1 copy, so I can only undistribute 1 copy. There's no number here, or if there is, it's 1. So the only thing common to both of the first 2 terms, in terms of the number, is 1. And again, you can write 1, but you don't have to. What's left over? X plus 2. X times x is x squared. X times 2 is 2x. Bring this sign down. What's common to these 2 terms? 6. What's left over? X plus 2. What's common to these 2 terms? X plus 2. And what's left over? X plus 6. How do you check? How do you know that that's the right factorization? Well, redistribute. X times x is x squared. X times 6 is 6x. 2 times x is 2x. And 2 times 6 is 12. Combining like terms gives me 8x, so this is the correct factorization of this expression. Here's another one. Find your product and your sum. Product is 1 times negative 15. The sum I'll be looking for is negative 2. How can I build negative 15? Well, I can either go negative 1 times positive 15 or positive 1 times negative 15. I'll get negative 15 as a product either way, but when I add them together, this is going to give me a positive answer, and this is going to give me a negative answer. I want a negative answer, so I want the product where the small number is positive and the large number is negative. How else can I write 15? 3 times 5. I need this product to be negative, so one of these has to be negative. To get a negative sum from these same two numbers, I need the larger of the two to be negative. Look, there's the number I was looking for, negative 2. So that means positive 3 and negative 5 are the right combination to use to rewrite the middle term. Plus 3x minus 5x. Now that I've got 4 terms to play with, let's find the GCF of these two and these two. What's common to x squared and 3x? X. What's left over? X plus 3. Bring this sign down. What's common to 5x and 15? 5. What's left over? I already brought the minus down, but what that means is that I'm multiplying or undistributing by negative 5. So negative 5 times what is negative 5x? Well, that would be x. Negative 5 times what is going to give me negative 15. The number is 3 because 5 times 3 is 15. But what sign goes here? A negative times what is a negative? It's a negative times a positive that's going to give me a negative. Well, that's good because that means that these two are identical. If I'd put a minus there, they wouldn't be the same, and I couldn't do the next step. What's common now to these two terms? That's x plus 3. What's left over? X minus 5. This is the factored form of this trinomial. Don't believe me? Distribute. X times x is x squared. X times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. Combining like terms gives me x squared minus 2x minus 15. And that's what I started with. So that means that this is the correctly factored form of this polynomial.